This is a 1983 R100RS, and I'm going to remove all of the electrical components under the front engine cover. That includes the diode board, the alternator assembly, and the electronic points. To get access to that, one of the first things you do is pull off this front engine cover with 2 bolts. But before you ever pull the front engine cover, always disconnect the battery ground terminal. And of course my engine's out of the bike, so that's been disconnected. The reason for that is when you go to pull the engine cover off the bike, this is the diode board, and the frame of the diode board has power. If it touches the cover, it'll short it out, and you get to buy a new diode board. Now, I'm also going to need to get some access to some of the wiring up near the top of the engine. So I pulled off the top engine cover, which sits up here over the starter motor, and it too is just secured by 2 Allen bolts, so very easy to remove. I thought I'd show some of the wiring that goes to the alternator. This is the cover, and there's a set of wires that come in. These are the 3-phase wires that are going from the stator, and they go through a cable that goes up to the diode board and connects in the back. And there's one other wire that comes off the stator here, which is called the Y, or center tap wire. And it also goes up to the diode board, but over here on the left side. The 2 other wires are for the brushes. So there's a brown wire and a black wire. The brown wire is the ground, and the black is not grounded. Consequently, this is a bolt, but you'll find when you take it out, there's a set of insulators to keep this whole assembly from grounding through the stator cover to the engine block. There are 3 sub-harnesses that come out of the top of the inner timing cover, which go to the electrical components inside the front engine cover. There are a couple of wires that come up out of the top of the engine. This one with the sort of T-shaped connector goes to the voltage regulator, and it has a black wire, a brown wire, and 2 blue wires. The black and brown wires are going to go to the alternator, and they actually are what go to the brushes. This is the brown wire, and this is the black wire. And the blue wire is coming from the generator light in the instrument cluster, and it's used to provide a small current to flow through the rotor so it'll be magnetized, and when you start the motor, then that magnetization allows electrical power to be generated in the alternator. There's another wire that comes out of the top of the engine toward the rear and has this special connector which goes to the ignition control unit that mounts right where the brake master cylinder lines connect on the spine tube. And it has a connector on one side which has a green-blue wire, a brown wire, and a black wire. The green-blue brings power to the coil from the ignition system. The black wire is part of the ground path, and the brown wire is a true ground. So those wires are going into the special connector. Now there's another wire out of the connector that goes into the engine, and it actually connects down here to this plug, which goes to the electronic points. So in here are 3 wires that are part of the electronic points system, and they act as the trigger to the electronic ignition control unit, which is what's plugged into here. There's another large cable that comes out of the rear of the top of the engine, and this is what goes to the positive battery terminal, so it's a pretty thick gauge. Now the other end of that connects to the starter solenoid, and then this I pulled out of the starter relay, but it brings power into the starter relay from the battery. So that's a kind of a quick review of the various wires that are coming out of the top of the engine. The diode board is connected on 4 studs to the block, and mine has a self-locking nut and a flat washer on each of those studs, which I've removed. And then you can just slide it off the studs. And there's the connectors on the side. This one goes to the Y terminal on the alternator, and this goes over to the starter solenoid, which is the power output from the diode board. On the back of the diode board are 2 connections. This one is a wide connector with 3 big wires. Each of them is one of the alternator phases. So this is input to the diode board from the alternator, and it's AC voltage. This small connector has a blue wire which goes to the voltage regulator, and I had to make a little repair to this when I first got the bike. I'm going to replace the whole cable now that I'm tearing into this. So they're a little hard, which is good because you want them to be nice and tight, but they pull right off the back of the diode board. Now you can see on the back of the board there's the 3 pins for this wide connector, and it can plug in one way or the other. Either way, it does not matter. And then over here you'll see there's 2 pins, a vertical and a horizontal. They're identical. You can plug the blue wire into either one. It doesn't matter. So now that I've removed the diode board and I've got the little blue wire off the back, that's all part of this harness that includes the voltage regulator T-shaped plug on one end. And along this harness is another wire that goes to a terminal on the starter solenoid, which I think you can see. It's sitting right here. So I'm going to pull that off because I want to remove this whole harness, and I'm just going to give a tug, and I got that one off the starter solenoid. And the other 2 wires in this bundle go to the brushes, and they just pop off as well. So I'm going to replace this harness because there's this damage that I have on the lead to the blue wire. But this is the voltage regulator harness, all removed, and we're sort of making progress. So at this point I can just pull off the center tap or Y wire right off of the alternator, and down here are the 3 phase wires, and you can see that cable goes all the way back behind this tab to the special 3-prong connector. So these can be pulled off just like that, and then you can snake them out, and that's the special cable for connecting the alternator output to the diode board. There's another wire that was the DC output from the diode board, and that connects over here to the starter solenoid, this big terminal. So I can back that nut off. That'll let me remove the this is the large cable that's the plus battery terminal, so that's charging the battery. And then if you look right here, this is that wire end from the output of the diode board. So I can get all that off. So I've removed the hardware, which was a thin nut and lock washer. And the first piece to come off is the large terminal for the battery plus cable. And this is the other end of that output wire that brings DC voltage out of the diode board. Notice the ring terminal here has to be bent to a 90-degree angle. And that's because there's very little clearance in here for the wiring. And right in here, this whole assembly has a hose connected. This is the crankcase rebreather, so things get real tight in there. Now I can get the cable out that comes off the diode board. It's going to want to catch on things because of that 90-degree bend in the terminal, but there we go. Alright, so that's that little wire, which is an important component because if there's any problem with it, your battery's not going to charge. I'm ready to separate this connector, which is the wiring that goes to the electronic points. And there's a wire bail here that keeps them connected. So I'm going to use a small screwdriver and come in here on the side, and I can pop one edge of the bail up and over, and then I kind of have to go to the back and get underneath it to get the other side of the bail to pop out of its groove. It's a little fiddly, but they finally come loose. And that's the little wire bail. And at this point I can just disconnect the plug that goes to the electronic points. Now the other side of the plug is attached with some zip tie, so I'm just going to snip that and free that plug end, and then we can remove this whole assembly out of the engine. So here up at the top on the back are the two wires that come out of this back hole. This is the great big cable that goes to the battery plus, and then this is the connector that goes to the ignition control unit. So you can just slide them back, and then you can get everything to pull with a little bit of work up and out. Of course, this boy here is going to fight me, but in any event, that's the idea for how you get this whole cable harness out. So I have that whole assembly out. This was the rubber grommet at the top of the case. This is the big ring terminal that goes to the solenoid, and then the second is the connections that go to the electronic ignition system. So all of that's out of the bike. So I'm ready to remove the alternator, and I'm going to start by taking off the stator cover along with the stator wiring, and that's secured by these 3 Allens. So I'll just back those off, and then I can pull the whole alternator stator assembly off. Now that I have the cover bolts out, which are fairly long, skinny Allen bolts, I'm going to remove the spring that pushes the brush down, and we'll pop that up and off like that. And then the other one's kind of fun, so it's buried in the back. Now the stator assembly includes this cover and this steel ring and the coil of wire that makes up the stator, and it's assembled up against this little lip. So what I do is I get my hands in, there's 3 of these cutouts, I can get my hands in all 3, and I want to pull the whole assembly out as a unit. So now that the brushes are off the slip rings, by the way, when I first did this, I forgot to take the brushes off, the springs off the brushes, and you see what happens? When I pulled this forward, it broke the brush holder. So you want to be sure you get these coil springs off the brushes, so the brushes are loose before you pull this cover. This doesn't matter because I'm replacing the whole alternator and upgrading it anyway. But as I say, I get my fingers back inside the 3 little slots, and try to pull the whole assembly, and it'll slide right off. So here's the stator cover, and then this is the magnet sleeve, the steel sleeve that fits around the coils, and these can be separated, but what's holding it together are that there's still wires connected here and here. So in general, if all you're doing is pulling this off because you're going to work on replacing a seal or something like that, just keep it all together. The other thing is that on the edge here is the Bosch tag, which tells you which alternator you have, and the important number is the 005. It also tells you it's a 14 volt 20 amp. So this tells you how much power this particular alternator is going to be delivering. To take off the rotor, I have to back off the rotor bolt, which is an Allen head. And of course, the minute I do that, the whole rotor is going to want to turn. So my little trick is to take a oil filter wrench, which conveniently will fit around the iron fingers of the rotor, and then I can get it to back off. So I'm going to back that out entirely. Now what you'll find is you're able to get the bolt out, and then it'll stop because there's another set of threads. So just kind of tug on it, and you can get that bolt to come out of the second set of threads. And there we go. And there it is. So that's the rotor bolt and its little lock washer. Once you have that rotor bolt out, you're still not going to be able to get the rotor off because it's a tapered interference fit, and so everything is solid on that shaft. What's required is a special hardened bolt, which this is an example of it, and the threads have been machined off, but it's hardened so it'll take the force without mushrooming the end, and that's pretty important. So the way that works is you just stick it in, and then you just tighten it down until it won't go any farther, like that. And then you put a socket on the end, and of course it's going to want to tighten up again, so use your oil filter wrench to immobilize the rotor while you tighten this. Now as you tighten it, it'll finally pop, and so you want to make sure you have either a hand on it or with the oil filter wrench. That's probably going to keep it from dropping on the floor. Okay, I got it to pop loose, so I can just pull it off, and you can see what I mean. This is a tapered fit on the crankshaft nose, and the inside of the rotor is tapered. They actually are what keep it from spinning on the shaft, and the bolt that's in there is just to kind of keep things from going anywhere, but quite honestly, it's that interference fit between the tapers that's what keeps the rotor on. So we have the alternator removed at this point. To remove the electronic points, it's secured by a couple of Allens on each side, and I've already got that one out on the other side, so it's pretty straightforward. Just back it out, and a certain amount of crud on that one, and then the whole can will slide right out. And there's the pins that engage the camshaft, and it's a sealed, I shouldn't say sealed, but it's a closed unit, so it comes right off. So we've got that off now. So I've removed the diode board, the whole alternator, and the electronic points. But there's one other detail that I'd like to talk about here, and it's up where the diode board mounts are. And you'll notice there's a whole lot of brown wires connected like octopus tentacles. So there's one here, one here, one here, and they all go to a bolt right here in the engine block. And as a belt and suspenders, there's another wire here that goes to this bolt, which goes into the engine block, and another wire here that goes to this bolt that goes to the engine block. The problem is the diode board needs a solid good ground, but this whole case has been painted or powder coated, which makes it insulating. So they want to guarantee a good solid ground, and that's what the octopus wires are all about. One other point to make is that when this engine was built, originally the diode board mounts were rubber. That required them to have these extra wires to get a good ground. The bad news with the rubber mounts is they were trying to fix a problem with diode board failures. They thought it was vibration. It wasn't vibration. But the rubber breaks, fractures over time, so it's not a good answer. After I got the bike, I replaced all the rubber mounts with solid metal mounts, and I kept all the ground wires for the reason that, as I say, this is painted, so I want to make sure there's a good solid ground there.